this lesson plan, we're introducing a new unit of work. So hopefully you should have in front of you the unit plan documents and the unit plan drawings. So the unit plan, engineering skills, welding and fabrication. The primary learning and assessment objectives, an introduction to structural engineering principles and reinforcing, stick welding and compound mitre cuts. And the context for that will be fabricating a sawhorse. So sometimes referred to as a saw stool, sawhorse, either way is quite fine. There is homework. The homework will typically be reviewing and watching some preset YouTube videos that are based on this project or based on some other project where the information still applies directly. Or it'll be having a look at some particular websites that apply to what we're doing. The tasks, there's 4 basic tasks. The first one is demonstrate an understanding of basic structural principles. Then go to stick welding, compound mitre cuts, and then the fabrication of the sawhorse. So the sawhorse is only a part of the task and the assessment. All these other parts are part of it. We can't just focus on the sawhorse, but as much as possible we're talking about it in context with the sawhorse. Understanding structural principles might seem a little bit too high or a little bit too detailed. But what I've done is I've broken it down into some of the very base principles. Most of them you'll already be familiar with. And as we talk about them, you'll recognise them from what you've seen around you and just from what you've experienced. Some you won't have, but we're also introducing the correct terminology. So when you're talking about how much something bends, so if I get a piece of timber and bend it, how much it bends is called deflection. So for instance, it'll be terminology and principles that we'll be introducing. It's all going to be contextualised around the sawhorse. Most of the time, a lot of people might think of engineering as designing or building a bridge or skyscraper or some huge building. I'm contextualising engineering into design or construction of anything that needs to be strong or strengthened to function properly. I'm including something like this little bracket. So this bracket needs engineering principles in order to be strong enough to do the job it's meant for. This cast stand. So these are different things we'll talk about a little bit more. The cast stand needs some engineering principles to be strong enough to do the job it's required for. Even this computer side panel off a desktop computer, we can see the engineering principles in this. Other things that we'll be looking at is a trolley jack. What are some of the engineering principles we can see in there to make it stronger, or to make it strong, or to increase its strength so that it functions properly? Yachting, the mast on a sailing boat. We'll see some of the principles that we're talking about, we'll see in yachting masts. The drawbar on a trailer or a caravan. We're looking at examples of the engineering principles that we're working with in them as well. The first part is the engineering principles, then comes stick welding. So the sawhorse that you'll be building will be a steel, or mainly steel, predominantly steel. This is an old timber one. It's been around for quite a while. It's good and solid. But the one that you'll be making, the legs, the basic structure underneath is all going to be steel. And relatively small section steel. So we'll be working predominantly with SHS, which is a square hollow section, a 25 and a 20. So one that fits in over the top of the other. The other materials that we're using for the sawhorse is we're going to be using a timber top plate. Now, as you can see, that timber top plate on this one is quite thick, whereas this one is only 19 millimeters thick, so it's much thinner. And on top of that, the distance between the supports on the one we're designing or making is much greater as well. We'll also be using steel strap underneath it. I'll get to that in just a moment. So let's have a very quick look at just a couple of pages of the drawings. Here's our first page. There's the saw stool, sawhorse. We've got the short stubby legs with a small tube that fits inside them. So it's a telescoping system. Those legs pop out, then they fold up underneath. So those legs fold up underneath the saw stool. It becomes a step stool. Saw stool, sawhorse. And I keep on changing the way I refer to it, but they are effectively one and the same. The page I'd really like you to have a look at the moment, though, is the very last page. So on the last page, there's an anticipated delivery and assessment schedule. So it gives a week-by-week outline of what's intended to be done on any particular week or any particular lesson. So that way you'll know what it is that you should be doing. You'll know what homework, as far as videos, whatever, you may have to watch to learn some of the procedures. So we will be working through the procedures in class, but if you've watched them beforehand, it'll be easier for you to pick it up and run with it. So this last page will be a fairly critical one. It also gives an outline of the different assessments that we work through. Now there's one particular feature, and it's a deliberate feature in this project. This is an old saw stool, and it's still very, very solid and safe. It rocks around a little bit of rot occurring on a couple of the legs, but it's really solid. By contrast, this timber is much thinner. And if I stand on it, you'll notice it bends. I can bounce on that a little bit. There's a little bit of bounce and movement in it. So, first off, I'm going to measure how high it is at the moment. And that comes in at 121 millimeters. If I stand on it, it's starting to bend a little bit. It's now 111 millimeters. So it's actually bent by 10 millimeters, which we refer to as deflection. Deflection tells us how much something has bent. We would generally say that this is under design, in that it hasn't been designed strong enough for the job that it's required. And that was done deliberately in the design of this project because I want to introduce the concept of structural reinforcing, and that's what these straps are doing on the back. They are structurally reinforcing this to make it stiffer so it won't bend as much. So let's try that by comparison. Once again, I'll measure this in the centre. It's showing 123. Stand on it. And 121. So it is only bent by 2 millimeters. So previously, that one bent or deflected by 10 millimeters. By adding these reinforcing straps to the back of it, it now only bends by 2 millimeters. So that's quite a significant change. We will also talk about other ways to make it even stronger if you wanted, so that the weight of a person on it wouldn't bend at all. But with only 2 millimeters deflection, that's a fairly good result. So as I said, the context of what we're learning is based around this sawhorse. And the sawhorse has been deliberately under-designed. So it's not designed strong enough in the initial context. So it's needed some extra work being added to it to reinforce it. So we'll be looking at reinforcing the structural engineering principles. And one of those principles is reinforcing items. And we'll be applying it to this and applying it to a lot of things that you would have already seen around you. So it should be a fairly enjoyable unit plan. Getting to play around with different tools and learn different tools. Learning welding and understanding compound mitre cuts. There'll be grinding to do, etc. So there's a little bit in it, but it should be quite enjoyable. So thank you for watching the lesson.